All right, so 4-7, we're going to talk about inverse trig functions. Arc sine, arc cosine, arc tangent. Now, that's just a different word, but I want you to look at this right here. Arc sine is exactly the same as the inverse sine. It's a different way of writing it and saying it. Sometimes we'll use one in placement of another. So they mean the same thing. All an inverse means is that we're trying to find theta, the degree measure, but it's always in radians. So your answer when finding the inverse must always be in radians. So for some of you that'll be an issue because you don't like the whole radian thing. Yes, that's you. Oh, you're agreeing. All right, so you can only find the inverse in these quadrants, right here to right here. Now, if you want to know why, I could tell you, but then I'd have to kill you. What? No, just kidding. If you want to know why, you can look in your book on page 349 for the whole explanation. But I'll just try to make it brief. Do you remember when we were finding inverses of functions and we traded out x and y and we found the inverse of a function, right? Solve for y. Yes. And if you took that inverse function and put it back in the original function and went through all of the operations, shouldn't you have come out with a value of x if they were true inverses of each other? Remember doing that? Well, we did. And so there are some restrictions on this, and based upon those restrictions, we are restricted to certain quadrants. So if you want to read all about that, it is on that page. I don't think you really care about that, to be perfectly honest.
Nope.
So let's look at, first of all, put yourself must know here.
Can we have like some kind of cheat sheet for this test, please? I think.
No.
What if we like
No.
what if we point to just
By yesterday, you should be feeling so much more comfortable with all this. You really should.
I remember everything.
I understand everything.
You're gonna have some work to do this weekend.
No.
Well, you're gonna have to make some time. All right. So recall that this is 0. Pi over 2, pi, 2 pi.
Was it good enough?
So if we had the sine curve, remember sine went at 0, then it goes up to 1 at pi over 2, back down to 0, down to -1, and back up to 0, correct? So this is pi over 2, and this is negative pi over 2. And this is 1 revolution of pi. 1 period. In addition to that, I talked about the fact that the sine curve is essentially the unit circle unwrapped. So this is 0 degrees, this is your pi over 2, pi, and 3 pi over 2. And then this is 2 pi. Well, hang on, let me continue. So these are your key points, right, on your first period of pi. And at each of these key points, for instance, at 0 degrees, remember that sine is the y value of that ordered pair. What is the y value of that ordered pair? What's the ordered pair at 0 degrees? 1, 0, right? And isn't y 0? That's why at 0 degrees, the sine is at 0. At pi over 2, the y value of that ordered pair is at 1. At pi, the y value of that ordered pair is 0. And at 3 pi over 2, the y value of the order pair is -1, and at 2 pi, it's back to 0. So that's how it became unwrapped from here and went into this beautiful little curve, okay? So we have restrictions, and it's saying here, you also can't have a value on an axis from -pi over 2 or pi over 2 for tangent. What is tangent again? What over what? Sine over cosine. Okay? And when is, so cosine's in the denominator, right? And when is cosine 0? Cosine is x. Isn't cosine 0 here? At pi over 2 and 3 pi over 2. Well, this says -pi over 2, right? Isn't that just going the opposite direction? We still get to 3 pi over 2? So that's why at tangent, you can't have values there. That's all that I'm saying so far, right? So what I would like you to do, you just need to know that we can only have inverses for sine, which would be arc sine, in the first and fourth quadrant. You can only have inverses for cosine in the first and second quadrant, and for tangent in the first and the fourth quadrant. Also bearing in mind that sine and cosine are restricted between -1 and 1, because isn't that the height of the sine and cosine curve? Right? The normal height. And then tangent and cotangent aren't restricted in that respect for x, because they go infinitely up and down, don't they? Okay. So there's some restrictions here you need to be aware of. So for example 1, we're going to find the inverse without a calculator. You have to find theta in terms of radians. Gabby, come up here. Or Gabby. Abby, come up here and get one of these. Gabby.
Same thing.
Not really. It's in that top folder. Okay. So I've given you the steps here that you have to follow. You have to first find the quadrant that we're talking about, use your reference angle, and find the value in the correct quadrant in radians. So I'm going to remind you again that we can tell where sine, cosine, and tangent are positive by using all students take calculus, right? So that's going to come back to haunt you. So for step 1, for A, we're finding the arc sine of -1/2. Where we have to look to see where sine is negative. So the very first thing, sine is negative in what quadrants? Because sine is positive here, right? So sine has to be negative in 3 and 4. So in quadrants 3 and quadrants 4. So that's where sine is negative. But where can you have arc sine? Arc sine, look above, is only in quadrants 1, right, and 4. Where do they overlap? So I know that my quadrant is going to be quadrant 4. So I have to look at where the inverses sine, cosine, or tangent is normally positive or negative, depending upon what they've given me here. And then where you can have that arc, sine, cosine, or tangent, and then look to where they overlap. Okay, so I know, this is step 1. I now know in step 2 that I am in quadrant 4. So make a reference triangle, theta. That's where my reference angle is. And isn't sine opposites over hypotenuse? So my opposite from this theta is 1. My hypotenuse is 2. Isn't y negative in the fourth quadrant? So that's a -1. I could find the adjacent side, but it's no need. When theta's across from 1, what degree is that? So if theta is 30 degrees, what is that in radians? Pi over 6. Well, is pi over 6 in the fourth quadrant? No. So negative pi over 6x. Because remember, well, we're going to go with theta is negative pi over 6.
Is that an answer?
Is that all we have to do?
That's all you have to do.
Can we stop now and just do it?
It's pretty much, that's pretty much what we're doing for the most part. So let's just do it again, okay? If you don't, all you have to really focus on is where can this be? Because you already know where the others are, right? All right, so let's look at sine again. Or this is, aren't these saying the same thing? Just using different notation? This and this right here mean the same thing.
What the same for every
Yes. Yep. Yes.
Just a quick question. So, since they're the same, does that mean that on our calculators we do have an arc sine ability?
Mm-hmm.
Because
And I'll show you how to do that with your calculator in a minute.
I think I use that.
Bless you. Yes.
Does that mean arc sine is to negative?
No. No. It means it's the inverse of the sine. Sine to the negative 1 means
I know,
1
I know,
over.
I know. I'm
Yeah.
just
Okay.
making sure.
Okay.
Yeah.
All right. So this time our inverse is positive for sine. So where is sine positive? So sine is positive in quadrants, all students, 1 in quadrants 2, right? Arc sine can only be in what? Is only in quadrant 1 and quadrant 4. Where do they overlap? 1. So then I know I'm going to draw my reference angle. I know I'm in quadrant 1. There's my theta. So sine again is still opposite over hypotenuse. So opposite is radical 3, and my hypotenuse is 2. I don't have to fill that in. You can if it makes you happy. So theta is what degree? Because it's across from radical 3, theta is 60 degrees, bless you. And so what is our theta in radians in the first quadrant? Pi over 3. Yes. They will. Good question. They will overlap. Okay, then we're going to use our calculator. We've actually done this before. Because we want our answer in radians, you're going to find theta. Your calculator needs to be in radians. Yes. Yes, you know where they are? Okay. All right, so instead of, we don't have an arctan button on our calculator, do we? What are we going to use? Yeah, but first go to your mode, right? Go to mode. Is my calculator in the correct mode? Yes. So radians should be highlighted. So instead of arctan, we're going to use, look above the tan here, we're going to use tan to the negative 1. So the inverse tangent of negative 8.45. Remember, when we do the inverse tangent, we're actually finding theta. And so theta is approximately equal to go out to 3 decimal places. 453, because there's a 0 following the 3, right? So negative 1.453. So then I would like you to find these two.
Wait, that's it?
That's it. Easy peasy, right?
I like this section.
That's not bad. Wait till we get on the back.
There's no such thing as the back.
Uh-oh, did something happen?
Yes.
Huh. Let's talk why.
You know.
Okay, so when you did cosine to the -1 of 2, everything went wonky. Ah, error domain.
What is the actual
What number are you putting in for x?
0?
What do we put in for x? 2.
Not put 2 in for cosine.
What are the only x values that cosine is?
0 and 1.
0, 1, and -1, and numbers in between those, right? As it follows around the unit circle, it never gets higher than 1 or -1, does it? So can we put 2 in? Remember that restriction for sine and cosine? Sine and cosine, you can't do the inverse sine of numbers greater than 1 or less than -1.
So theta is.
If you do the regular cosine,
So N.
Of 2? Try it.
yeah, it works.
Yeah. All right, so write yourself the following notes. Not possible. And the reason for that is that cosine and sine must be between, because you'll forget, -1 and 1. And the reason for that is because that is the height of the sine cosine curve. So then flip it to the back. This is where a highlighter would be handy because Mr. Gleason, bless his little heart, summarized everything we just talked about. Right back here.
Are there going to be issues, like mistakes on here? Can I still type in the
Well,
numbers?
no. So, remember I was talking about if you put the inverse into the regular function, you get the value of x? Notice that whatever the arc sine is of whatever this value is, let's just call it x. If you take the sine of the arc sine, you should get this value right here again, because they are inverses of each other. So if these are inverses of each other, you should get that value right there, x. Okay, if that's a 5, won't you get a 5? Although, could you put a 5 in? No. So let's say 1/2. So if you put 1/2 in, you'd have 1/2 here. Okay? Then, well, I don't have another color highlighter. I've lost one since last year. This is the next section, and all it's saying is it's reversing the inverse and the regular function. So the arc sine is now outside. So it doesn't matter whether you have the arc sine of the sine or the sine of the arc sine. Whatever this is, that should be the answer. So long as you follow the domain restrictions. And so that's what follows here. These are the domain restrictions right here. Little boot, so you can write yourself a note, domain restrictions. Oh, I guess it's really range restrictions, isn't it?
Seriously.
Wasn't it range on the vertical axis? Really your range restrictions. And then remember we have the restrictions in the particular quadrants. So, where's my purple go? Oh, I have it. What quadrants are between, are less than pi over 2 but greater than negative pi over 2? What quadrants are they talking about? 1 and 4. Greater than, remember, this is, right over here, this is negative pi over 2. So it's greater than negative pi over 2, but less than pi over 2. We're talking about these two quadrants. And where can sine only be? The arc sine? 1 and 4. Same thing with tangent, right? But with cosine, it's 1 and 2. 1 and 2 is between 0 and pi, isn't it? whoops, between 0 and pi. So look at these restrictions here. So for cosine, it has to be between 0 and pi. Isn't that quadrant 1 and quadrant 2? Tangent has the same restrictions as sine. Quadrants 1 and quadrants 4. So that's all that that part is saying. It's just saying it in terms of radians. And that's why our answer to the very first problem, because it had to be in between these two radians, had to be negative pi over 6 for the first one. Because negative pi over 6 is in between these two, right? You have to have an answer that's in between those stated values. Okay, so let's find the following. So look at example 3. What is the tan of the arctan of negative 5? Negative 5. Right? Question? You okay with that? Okay. Well, you hope for those, right? What is the arc sine of the sine of 5 pi over 3? However, is 5 pi over 3 in between these two numbers? Ooh. So let's draw a picture. So write yourself a note right here that 5 pi over 3 is not, so here's where the problem arises, is not in between, or not between, pi over 2 and negative pi over 2. So we're going to find a reference angle. Yes. So where is 5 pi over 3 normally? There. Here's 3 pi over 3. Oh, I'm sorry, this is 3 pi over 2. Okay, so pi over, what am I looking at? Over 3. Okay, so this would be 1 pi over 3, correct? 2 pi over 3, 3 pi over 3, 4 pi over 3. Wouldn't 5 pi over 3 be in the fourth quadrant? So the terminal side of this radian measure is in quadrant 4. Our arc sine has to be in quadrant 1 or 4, right? So the fact that it's in quadrant 4 works. We have to find this angle measure right there. So is it going to end up being negative? Because we're going to go from here down.
So yes.
So how many pi over 3 is left over here? 1. So, I mean, theoretically, you can think yourself through it that this is negative pi over 3, isn't it? Isn't it? Do you see how I got that? If this is 5 pi over 3, there's only one more pi over 3 to get to 6 pi over 3, which is 2 pi. So that means if I go backwards, isn't that negative? Isn't that negative pi over 3? That's your reference angle. So your answer ends up being, if we rewrite it, I lose what color? So this would be number 2. So number 3. You could rewrite it as arc sine of sine of negative pi over 3. So what's your answer now? Negative pi over 3. Theoretically, that's what we just did. We replaced 5 pi over 3 with the negative pi over 3 because it falls in that range that we're looking for. Okay? What's wrong?
You get it.
You get it? Good. Okay. So then, isn't this is no different than the cosine of the arc cosine of pi, right? Was she plugged it into her calculator? Is that what you just did? Ah, but you're supposed to do it without your calc. But your calc did give you an error, didn't it? Why? Look at cosine. Cosine.
It's not less than pi.
Yeah, but it's just less than equal.
Oh, yeah, it's equal.
That's why I thought it would be.
Okay, so it seems like it would be okay, right? So let's look at the unit circle or the coordinate grid. And then pi right here would go to that terminal side. So this would be the terminal side here, wouldn't it?
Can't remember angle on that. That's everything.
That's the ones that you do.
It was pi or negative.
What is the value? Okay, this is the value that we're putting into it, right? It's not the answer we're getting out of it. What is the decimal equivalency of pi? Okay, so pi is approximately equal to 3.14. Remember, we're putting that 3.14 in for cosine. Can you take the cosine of any number that's outside of 1 and negative 1? No. And so that's why, which is not between negative 1 and 1, which is the height of that cosine curve. So it's not possible.
Well, I don't understand. Like, how is that not possible? Yeah, but okay, we don't know what pi is exactly.
It's 3.14 though. Approximately, right? Isn't that way, it doesn't matter how close we get to it, it's still way far away from 1, isn't it?
Yeah.
It's not like it's 1.14.
I thought
So-
we were looking at 0 in there. 0 is less than or
But the
equal to 1.
value that we're putting in to find the cosine of,
Yeah.
even though it's the inverse cosine, is outside of the parameters of 1 to negative 1. That's why when she did the arc sine, or I'm sorry, the cosine of the arc sine, the inverse sine, sorry, try that again. The cosine of the arc cosine of pi in her calculator, what did you get? She's totally ignoring me. Dakota, what'd you get? Error, right?
Well,
So-
no, I get that, but like, I think that's just the calculator can't comprehend if the number goes on like that.
No. But remember, the cosine wave itself doesn't go higher than 1, or it doesn't go lower than negative 1.
Because so then which restrictions are you supposed to look at?
Well, it just depends. For this one, we looked at our actual reference angle. We had to have a reference angle in between here, because that's the restriction for the arc sine that we're trying to find. That one's on the outside. This is on the outside here, cosine, right? So my restrictions for cosine, I looked here. Depends on what's on the outside. My arc sine's on the outside here, I look to those restrictions. Right? Because I can't take an arc sine that's not in those quadrants,
Oh,
right? I can't take a cosine of something that's not within those parameters. So it does depend on what's out in front. Okay? All right, so then let's look at 4 and 5. So for 4, find exact values. That means no calculator. So there's a process to this. I'll do the first one with you, and then you ought to be able to do the second one. Okay? So this time we're finding the secant of the arc sine of 4/5. Secant is not the sine of the arc sine anymore, right? Well, but here's what we're going to do. We're going to manipulate things a little bit. Okay, so the very first thing is I'm going to find the secant of u. Of u. Yeah, haha, you're so funny.
Let's use
That means that I'm letting this be u. I'm replacing the arc sine of 4/5 with u.
I don't want to be a math thing.
Okay.
Could we do like,
Hang on.
make
Just I don't care what letter you use, just don't use X or Y. Okay? So I'm replacing it with u. And haven't we done this in the past before with things that look complicated when we did logs, right?
Yes, I love
Okay.
No.
Now you say that. All right, so remember that u is equal to the arc sine
you are equal.
of 4/5. Can I replace the arc sine with the inverse sine? Can I rewrite this so it looks like this?
Yes, you can.
I can do that, right? Don't they mean the same thing? So, do you remember when I was explaining to you how the inverse of sine, like 1 over sine, became sine to the negative 1? And I said, theoretically, we can't do it this way, but mathematically, algebraically, we'd think of it this way. What if I multiplied this side by sine, and I multiplied this side by sine? What happens to the inverse sine and the sine? They would cancel each other out, right? So my point is that if I rewrote this in black to say the sine of u is equal to 4/5, I can do that. You'll always see me doing it this way to remind you how I got from here to here. That means the sine of some degree is 4/5. Where is sine positive?
First and second.
Okay.
And the arc of that first.
Say that again, Matt.
And then the arc of second first.
Okay. So sine is positive in first and second, right? But the arc sine can only be where? First and fourth. Where do they overlap? So that means that I know that u, I'm putting u in here this time, is in the first quadrant. And because it's 4/5 and it's sine, isn't that opposite over hypotenuse? Yeah. So we're doing somewhat of the same thing that we did on the previous page. So opposite is 4, hypotenuse is 5. Yes, you're right. This has to be 3. Now, it is a Pythagorean triple. If you didn't realize that it's a Pythagorean triple, you can use Pythagorean's theorem to find the missing sides, or the missing side. It just so happened in this one it's a triple, but not all of you know your Pythagorean triples. So, I want to find the secant of u. I want to find the secant of u. Right? My whole goal is to find the secant of u. I use the sine of u to get my triangle set up. But my whole goal is I want to find the secant of u, right? The secant of that letter.
Second of that letter.
Okay, secant is the inverse of what? Sine, cosine, or tangent? Cosine. So cosine is whatever what? Adjacent over hypotenuse. And so secant would be hypotenuse over adjacent, right? So isn't secant 5/3? Yes, so technically, since I found the secant of u, the secant of the arc sine of 4/5 is 5/3. Because then I just replaced u with the arc sine of 4/5. I'm getting the hives just from it. Nice with her. Okay, last one. We're going to do the same exact steps. All right, now you're restricted on this one. You're restricted from 0 to 1/3. 0 to 1/3 for x. That's this x here. Why is x restricted between 0 and 1/3?
Because if it was 0, then when you can't have the cosine of 0.
Right, you can have the cosine of 0 and then, okay. This would have to come out, it can't be higher than 1, right? So it has to be somewhere between -1 and 1. So they're restricting it because where is, so let's find number 1. I'm going to let sine, I'm going to let arc of cosine of 3x, I'm going to just find the sine of u. I know we're doing that again. And remember, I'm letting u equal the arc cosine of 3x. So what do I do now? What did we do before? I want to change this symbol, right, or this notation. So I want u to equal the inverse cosine of 3x. I want to get rid of the inverse cosine. So don't I multiply both sides by cosine? Cosines cancel on the right, and I'm really going to find that cosine of u is 3x. So you're going to love this one. So then the second step is to figure out what quadrant we're in. Where is cosine positive? 1 and 4. Where can the arc or the inverse of cosine be?
No, it's 1 and 2.
It's only 1.
It's 1 and 2, it's only
1 and 2. So they overlap at 1. So again, I'm in the first quadrant, right? Oh, yeah, that's okay. And so then this is u, that letter. And cosine is what over what? Adjacent over hypotenuse. Now I put the 3x over 1. So that means adjacent is 3x and my hypotenuse is 1. I have to use Pythagorean's theorem to find that missing side because sine wants me to find the side opposite, right? This is fun. Are you ready? So step 3. Yep. So I'm going to just call this B for right now. So isn't 3x squared plus b squared equal to 1 squared? Would you agree? Yeah. What's 3x squared? So 9x squared plus b squared is equal to 1. How do you get b by itself? Okay, so I got 1 minus 9x squared. And then take the square root of both sides, right? And I get b is equal to the square root of 1 minus 9x squared.
Is that our answer?
This is another reason why they've restricted it to here as well. If you think about it. Because if you square 1/3, don't you get 1/9? And you end up with 0. But you can take the square root of 0. But b can't really be 0, but we won't go there.
Then why is it x?
All right, so b is equal to,
Wait, I don't know why x is like greater than or equal to or greater than. I understand like greater than or less than.
okay, let's come back to that in a minute. Let's just finish this first before we get bogged down in details. All right, so now I know what my side opposite is, right?
No.
I really want to find the sine of u, the letter, which is side opposite over the hypotenuse. So the side opposite is square root of 1 minus 9x squared all over 1. So we've actually found it, haven't we? So the sine of the arc cosine of 3x is equal to the square root of 1 minus 9x squared.
It's just long but not difficult.
Now here's why. X has been restricted in between here. Let's just take these right here, the boundaries. Put in 0 into here. Don't you get 1 minus 0? Square root of 1 is 1. Okay? That's in the parameters of cosine, right? 1. Then if I put 1/3 in here, 1/3 squared is 1/9. Times 9 is 1. 1 minus 1 is 0. Square root of 0 is 0. That's in the parameters of cosine as well. That's why. Okay?